All right, welcome back to the deep dive. Today we're jumping into something pretty wild.
Oh, yeah.
We're going after those really rare, kind of chaotic vintage tones from the 70s. You know, that raw, spitting upper octave fuzz you sometimes hear.
The good stuff, like those old French and Japanese circuits, right?
Right.
Super unpredictable.
Exactly. And that brings us to our mission today. We're digging into the MXR CSP203 La Machine Octave Fuzz.
Right, the Law Machine. A really interesting one. The goal here, I think, is to figure out how MXR's custom shop guys managed to capture that vintage, well, chaos.
Yeah, chaos is the word.
But somehow bake in modern consistency, reliability.
Which is the eternal struggle with vintage gear, isn't it?
Yeah.
So this came out, around 2013? And that custom shop label is pretty key here, you mentioned.
It really is. You got to understand, custom shop for MXR isn't just a paint job. It means limited production runs, hand-calibrated units. They're really aiming to recreate classic analog sounds, but critically make them tough enough for, actual touring musicians, pedalboard ready.
Okay, so let's set the scene. What vintage ghost were they actually chasing with the La Machine? What was the inspiration?
Well, the big one, the main blueprint, is really the spirit of the 1971 Fox tone machine.
The Fox. Okay, legendary pedal.
Absolutely legendary. And it's famous for basically two things. This incredibly saturated, almost compressed sound people call Velcro fuzz.
Velcro fuzz, I like that.
Yeah, it's sticky sound. And then those crazy piercing upper octave harmonics. It's not subtle. It's like mechanical aggression in a box.
And the name La Machine, French for the machine, kind of nods to that, doesn't it? That sort of mechanical sound, plus maybe a hint of those European origins.
It fits perfectly, connects all those dots. But, here's the real engineering challenge they signed up for.
Which was?
Those original Fox units. Notoriously flaky. We're talking serious sensitivity to room temperature, battery voltage drift. Sometimes even just plugging in a different guitar could throw it off.
Huh, yeah, sounds familiar.
So if you wanted that sound back then, you just accepted the instability. MXR's job was to somehow give players that same wild character.
But without the headaches, make it consistent.
Exactly. Make it work every single time you step on it. Pedalboard ready, like we said.
So how'd they pull it off? Let's pop the hood. What's the core circuit doing to get that saturated fuzz?
Okay, so at its heart, it's a discrete silicon transistor fuzz. They used high-gain silicon transistors, pretty similar to what you'd find in those old Fox circuits, or like Univox super fuzzes too.
Right, silicon gives it that sharper edge compared to germanium sometimes.
Yeah, and that choice is crucial. It gives you that thick, really saturated feel right away and helps deliver a ton of output volume.
But loads of fuzz pedals are high-gain silicon. What about that signature octave, that piercing upper harmonic? How did they engineer that part? Is it a separate chip? Or
No chip. That's the clever part, and it's very vintage-inspired. They take the fuzz signal and route it through a switchable octave-up circuit.
Switchable, okay.
And it's all analog. It uses a pair of diodes, basically set up to rectify the waveform.
Okay, rectify the waveform. Let's break that down a bit. What does that mean in simple terms?
Right. So think about your guitar signal. The fuzz circuit already clips it hard, turning that smooth wave into more of a square-ish wave, right?
Yeah, harsh edges.
Exactly. Then this diode rectifier circuit essentially chops off half of that wave and kind of folds it over itself. When you mangle the wave like that, it forces the frequency to double.
Ah, frequency doubling, which our ears hear as the note an octave higher.
Precisely. It's a pretty brute force way to do it, electronically speaking. But that's where all those cool, biting, synth-like harmonics come from. That's the magic.
Okay, so that's the old school method. But you mentioned the originals were unreliable. How did MXR fix that? What's the key difference inside the La Machine?
This is where that custom shop attention to detail comes in. The actual octave circuit, the diode part. It's almost a direct lift from the Fox design. It's very similar.
Okay.
But the big improvement MXR made was in the transistor biasing.
Biasing. Okay, what does improving the biasing mean for the person playing the pedal? What's the benefit?
Stability. Consistency. The old pedals, their octave tracking could be all over the place because the transistors were so sensitive to like heat or tiny power fluctuation.
Right, the infamous temperature sensitivity of vintage fuzz.
Exactly. The octave might fade out or get really weak or warble. By carefully designing the biasing, that's the specific voltage and current running through those transistors, MXR made the whole thing way more stable.
So it just works, whether it's hot or cold, battery or power supply?
Pretty much. They engineered the chaos to be predictable. if that makes sense. You get the sound without the drama.
Which is exactly what most players want today, right? Reliability is baseline, and I assume they included modern standards like true bypass.
Oh, absolutely. True bypass is a must. Means your core tone isn't messed with when the pedal's off. And that custom shop process added another layer. Each unit was individually hand-calibrated.
Hand-calibrated, wow.
Yeah, so they're making sure every single pedal coming off that limited line meets the spec, has that stable biasing, removes that luck of the draw thing you often get with vintage stuff.
Makes sense. Okay, let's quickly run through the controls for anyone who manages to track one of these down. Output, tone, distortion, and the OCT switch.
Output is simple, but watch out, this pedal has a lot of volume on tap. It can easily slam the front end of your amp into overdrive.
Good to know. Tone.
It's a passive filter. Turn it clockwise, it gets brighter, raspier, more cutting. Roll it back counterclockwise, and it gets darker, smoother, maybe even a bit woolly.
Woolly.
Right.
Okay, and distortion. That controls the fuzz intensity.
Totally.
Yeah.
At lower settings, you get that sputtery, gated kind of thing, the Velcro fuzz we mentioned. Sounds like it's struggling a bit in a good way.
Right.
Crank it up high, though, and it just turns into this massive compressed wall of fuzz, almost like a vintage synth tone, really thick.
And then the magic button, the OCT switch.
Yep. That kicks in the octave up circuit we talked about, the diode rectifier. And interestingly, the sources say engaging the octave also adds a slight volume boost.
Oh, that's handy.
Very player-friendly. Means when you kick it on for a solo, you naturally jump out a bit from the main fuzz sound. Helps you cut through.
Smart. So let's talk tone profile. Octave off. Just using it as a fuzz, what's the core sound?
Octave off, it's just a fantastic, thick, saturated fuzz. You get this grainy quality in the top end, but also lots of compression and sustain.
Yeah.
And the low end is huge.
Really beefy.
Yeah, seriously, a powerful low end. You might need that tone knob to tame it sometimes. Otherwise, it can get really woolly, which, again, is very reminiscent of the original Fox in its fuzz-only mode. Great for heavy rhythm sounds.
Okay, now flip that OCT switch on. Introduce those biting synthetic harmonics, the ghost notes. What kind of sounds jump out?
Well, the instant classic is that psychedelic lead tone, right?
Ooh.
Think Jimi Hendrix, Purple Haze kind of vibe. It nails that Octavia sound.
The definitive octave fuzz sound for many people.
Totally. But it's not just retro. It's killer for modern stuff, too. If you want a really aggressive, almost synthetic edge on heavy riffs, think Queens of the Stone Age, maybe some stoner rock that octave adds this cutting presence without making the sound thin.
Yeah, it can really make a riff stand out. Now, a quick tip is probably needed here. Octave fuzzes can be kind of picky about how you play them, right?
Oh, very much so. The sources really stress this. For the clearest octave effect, you generally want to play single notes and play them higher up the neck.
Like above the 12th fret.
Yeah, around the 12th fret and higher is usually the sweet spot. And also, using your neck pickup often helps. The signal is a bit rounder, smoother there, which seems to help the circuit hear the fundamental note more clearly and track the octave better.
Good tips. Okay, let's give the listeners a couple of starting points. Say someone wants that classic singing octave lead sound. Where should they set the knobs?
For that Hendrixy lead thing, I'd try setting the distortion maybe around 2 o'clock, tone, maybe a little brighter, like 1 o'clock, and obviously octave switch on in. That should give you singing sustain, but keep enough clarity for the octave to ring out.
Nice. And what about the other extreme? Maximum fuzz saturation, dark, sputtery, like a wall of sound for stoner or doom metal.
Okay, for that, you want to push the gain and darken it up. Let's call it the Velcro fuzz wall. Try distortion way up, maybe 3 o'clock or even higher. Tone rolled back, maybe 9 o'clock. And octave off for this one.
Octave off.
Yeah, that really lets the massive, woolly, low-end character of the core fuzz circuit dominate. Creates that thick, almost broken-sounding texture.
Gotcha. Placement in the signal chain, always crucial with fuzz. Where should this one go?
Early. Very early. Like, ideally, first in line right after your guitar.
Before buffers? Before other drives?
Definitely. Fuzzes like this, especially analog octave fuzzes, really want to see that direct, high-impedance signal straight from your guitar pickups. Putting buffers or other pedals before it can sometimes mess with the impedance and make the fuzz react weirdly, especially the octave tracking.
Okay, good rule of thumb. Fuzz first.
Yeah.
Now, we've mostly talked guitar, but this kind of intense analog texture must have uses beyond that.
Oh, for sure. In the studio, it's a great tool. You could, say, record a guitar part, twice, once with the octave on, once off.
Ah, double tracking.
Exactly. Then pan them slightly left and right, creates this huge, thick, slightly phasey stereo fuzz sound. Super cool effect.
Yeah.
And yeah, beyond guitar, run synths through it, bass lines, even drum loops.
With drum loops, really?
Yeah, if you're doing experimental stuff, industrial maybe, it adds this fantastic analog grit compression, that low-mid thickness, stuff that digital plugins often struggle to replicate authentically. It just mangles things in a really musical way.
Cool. Okay, let's zoom out a bit. Legacy. Where does the Lamb Machine sit in the grand scheme of Octave fuzz pedals? There are quite a few options out there.
It occupies a really interesting middle ground, I think. Tonally, it's kind of sandwiched between the really sharp, focused sound of something like a Dunlop Octavio, which tends to have less low-end warmth.
Right, more cutting.
And the original Fox Tone Machine, which was maybe even warmer, looser in the lows, and much more chaotic overall. The Lamb Machine sort of splits the difference tonally.
But crucially,
it delivers that specific flavor with modern MXR build quality and, as we discussed, that engineered reliability.
the best of both worlds, maybe? 70s tone, 21st century stability. Did it catch on?
Oh, yeah. It quickly gained a bit of a cult following among fuzz nerds. It's generally seen as one of the best, most faithful Fox recreations you can get, especially in a standard pedalboard-friendly size.
And being a limited custom shop run probably adds to the mystique now.
Definitely adds collector appeal, yeah. They aren't making them anymore, so finding one takes a bit more effort.
So wrapping up for the listener, maybe someone exploring fuzz history or just curious about cool dirt pedals. Why does the Lamb Machine matter? What's its significance?
Well, first, it successfully brought back a really iconic but often hard-to-get 1970s octave fuzz sound, made it accessible again. Second, it really showed off MXR's skill in not just cloning old circuits, but reinterpreting them, modernizing them, making them practical for working players.
Not just a museum piece, but a tool.
Exactly. And finally, by having that range from the core woolly fuzz to the piercing octave, it kind of proved this sound wasn't just a niche psychedelic thing. It's versatile enough for modern heavy music, alternative, doom, stoner. It broadened the application.
Yeah, it definitely bridges that gap. So this whole deep dive has traced the journey from that wonderfully messy 70s analog chaos to the meticulous, hand-calibrated, seemingly bulletproof engineering of the MXR Lamb Machine. They really managed to bottle that lightning.
They did. They made the chaos consistent. And maybe that leaves us with a final thought for you to ponder. If part of the magic, part of the very definition of that original vintage sound came from its instability, its quirks, its temperature issues, its unpredictability, what happens when modern engineering smooths all that out? Can you truly capture the spirit of something fundamentally broken by fixing its flaws? Or does taming the chaos inevitably change its soul?
Does making chaos reliable somehow diminish the chaos itself? That's a great question to chew on.